Hello. In this session, we're going to talk about the automated logic cost-saving strategy. And by this, we simply mean functionality that we've added to the product that's designed to save energy for the system. Now, there's a variety of ways to do this, but we're going to focus on 4 of the built-in features that come with Web Control. And this is provided as an overview. We have detailed descriptions and implementation information in the individual videos associated with each one of the 4 topics. So what I expect you to take from this session is just an understanding of what's out there, and then you can dig a little deeper in some of the more advanced videos. So we'll talk about schedules to start off with. Schedules is probably one of the most commonly used features, and of course, it allows you to schedule a zone occupied or unoccupied. So for instance, I can see that on Wednesday, okay, from 8 o'clock till 5 o'clock, this zone is scheduled to be occupied. Of course, at the other times, it's scheduled to be unoccupied. We often call that night setback as well. Secondly, we have what's called optimal start, and optimal start is inherent in any set point microblock that automated logic provides, and it essentially anticipates the need for heating and cooling at occupied time, and will start ramping up heating or cooling as necessary before the zones go occupied. Okay, we call this optimal start, and the idea is it really keeps people from having to schedule things like chillers and air handlers on 2 or 3 hours beforehand in order to meet the needs of the zone at occupied time. In other words, we'll send requests out before we're supposed to be occupied when we need to in order to meet anticipated needs of that particular zone. And that's called optimal start. We also have the concept of demand level, and essentially what happens is we have various set points associated with a particular zone. We have our occupied set points and our unoccupied set points, but we also have demand level set points. And let's take a look at the set point microblock real quick. And we'll open this guy up and move him up. And what we'll see is, in addition to having our occupied set points, our unoccupied set points, we have demand 1, 2, and 3. And notice that we've made these bands wider as demand level increases. Well, essentially, we receive a demand level broadcast from the meter when it's approaching a peak energy usage time, or amount rather. And that is then fed into the microblock, and we can reduce set points at the zone level in order to reduce energy usage. And by doing this, we can reduce set points 1 or 2 degrees across the board, use less energy, have less impact on the user, and fulfill our energy saving requirement. The last strategy we'll talk about, and we'll go to the air handling unit to do this, is trim and respond, or set point optimization. And this is simply a way of balancing requests against the drive to reduce energy. So what we're doing is we're working with the cooling set point for this particular air handling unit, and what we'll see in real life is as less requests come in, we'll start bumping that set point up in order to save energy. As new requests come in, we'll lower the set point to meet the needs of the occupants in the zone's comfort level. This is called optimized set point, or trim and respond. And again, there are more videos detailing the features themselves, but I just wanted to give you the overview of our 4 cost-saving strategies. For more information, see the individual videos.